All right, so assuming we're dealing with a positive number on the right, then the symbol tells us one of two scenarios is going to happen. If it says that it's less than c, then we would set up a what's called a three-part inequality where it's negative c is less than x, which is less than c itself. If it's greater than, then the greater than would say, let's set up one where we keep it positive, so x is greater than the positive, and x is less than the negative of the constant. Sort of, if you divide by a negative, then the inequality switches signs, so we bring the negative in, then it changes directions on us. So looking at two very simple examples of this, absolute value is greater than or equal to 3 says we're going to translate this to negative 3 is less than or equal to x, which is less than or equal to 3. So on a number line, I would go from negative 3 to 3, and those would be bracketed. And so our interval notation then, pretty straightforward. In the greater than case, so here we're saying x is less than negative 4, or x is greater than positive 4. So if we go to a number line, parentheses shade that way, parentheses shade that way, and this is where in interval notation the unions come up. Well, let's take this newfound set of knowledge and let's try to apply that to a couple of example problems. So starting with the absolute value of 3x minus 2 is less than 8. Less than means that I can split this up into negative 8 is less than 3x minus 2 is less than positive 8. And then I can go ahead and solve my three-part inequality. So I'm going to add 2 to all sides. So that'll give me a negative 6 is less than 3x, which is less than 10. And then I want to divide everything by 3. So that gives me negative 2 and 10/3, and those are both parentheses. Okay, and I'll just put that in interval. Okay, so next door, we've got absolute value of 3x minus 2 is greater than or equal to 8. So in this case, we get 3x minus 2 is less than or equal to negative 8, or 3x minus 2 is greater than or equal to positive 8. So we break it up into two different equations. I'm going to add 2, and it turns out that's the right thing to do for both of them. So 3x is less than or equal to negative 6, and 3x is greater than or equal to 10. And notice we seem to be getting the same numbers here, so it's very easy. All right, divide by 3, divide by 3. So it's very easy to lose track of the direction that you're facing these symbols. So both brackets, and they're going away from each other. So in interval then, it would be negative 2 out to negative infinity out to negative 2 bracket 10/3 out to infinity. Now notice I did not put brackets on infinity, I just put brackets on the two borders, the two defined endpoints of our interval. And so you never want to put brackets on an infinity symbol. Okay, in this next example, we have a fraction, but we've already got the absolute value isolated. So let's see, it's less than 4. So we can go ahead and do the three-part inequality on that. So negative 4 is less than x minus 2 over 3 is less than 4. And then order of ops. Well, if I want to get rid of that 3 next, so that means I'm going to multiply everybody by 3. So I have negative 12 is less than x minus 2 is less than positive 12. So notice those 3's divide out in the middle. Then I want to add 2 to both sides. So we end up with negative 10 and positive 14. Let's see, both parentheses, and we're shading towards. So negative 10 to 14 with parentheses on that. And our last example, I want to isolate out the absolute value first. So 1 minus 2x is greater than or equal to, I'm adding 4. So if I add 4 to the negative 1, I get 3. It's a greater than case, so I want to split it up into two different inequalities. So 1 minus 2x is less than or equal to negative 3, and 1 minus 2x is greater than or equal to positive 3. Let's see, both cases I'm going to add 1. Subtract 1. Whoops. Okay, so over here I get negative 2x is less than or equal to negative 4. And here I get negative 2x is greater than or equal to positive 2. Then I want to divide by negative 2. Okay, now notice our symbols are going to change directions because of that whole divide thing. So make sure it stays in the window there. Okay, so we end up with x is greater than or equal to 2, or x is less than or equal to negative 1. Okay, so in interval notation, we're going to hit negative 1 first, and I need to be careful. That's actually a bracket. Union 2 out to infinity. Okay, so I come over to my number line. Bracket that way, bracket that way. Okay, so let's take a look at what happens when the constant is negative. All right, so let's look at just some very simple cases and sort of problem solve in our head. If I had the absolute value of x is less than negative 2, is there any distance away from 0 that it can ever be negative? And the answer is no. Okay, so if I have absolute value of x is less than negative 2, that is a no solution. So we can either write it out as the empty set, so the number of answers that actually satisfy that are none, which is what empty set is, so we can just write out no solution. What about the absolute value of x is greater than negative 2? Well, how big or how often would we expect to find a distance, that a number that's positive, to be bigger than a negative? Let me kind of repeat that again, hopefully make more sense this time. How many times would a positive number be bigger than a negative number? Always, right? Because this absolute value of x is a positive, it's at least positive, or it's 0, right? It's one of the two characteristics of absolute value. It could be 0 away from 0, but it's always greater than negative 2, always, always, always. So that means that there is every single number that if I take the absolute value of it, I would get something bigger than negative 2. So that's always true. That's one of those things where I can shade the full number line. Okay, so that means then, so I can get this to scroll, that if we're dealing with an algebraic expression with some sort of inequality symbol, and the constant on the right happens to be negative, then it breaks down into whether it's less than or greater than. If it's less than a constant, that's no solution. And if it's greater than, then it's all real numbers. So it's everything actually satisfies that. so let's take a look at a couple examples and see if we can figure out ahead of time what's going to happen. So here, in this first case, we're told absolute value of 3x minus 2 is less than or equal to negative 8. We've got the absolute value already isolated on one side, and we've got a negative on the other. The less than tells me that there's no such number that I'll ever make that true. So this first one is no solution. Okay, same numbers in the second example, but I've switched the inequality symbol. Here it's greater than or equal to negative 8. Absolute value, this piece is always a positive or 0, one of the two. And how often is that going to be greater than or equal to negative 8? That's always true. All right, so then in the third case, it's not really obvious starting off which one we're dealing with. But if I do a little bit of manipulation, I can see pretty quick. Let's see, subtract off the 9. So I get negative 4. And then we'll divide by 4. So I get absolute value of 7 minus x is less than negative 1. So here I've isolated out the absolute value. It's less than, it's negative. So this is no solution.